Hello and welcome to Psych 3020 Measurement in Psychology with me, Mark Horswell. And this is your online refresher presentation that you should have a watch of in week 1. And this is what it's going to be about. So, first of all, we're going to cover all of the things that you must know as background for doing Psych 3020. And these are things that you should have been taught in previous courses, but that you may well have forgotten. What I'm going to do is test the content of this presentation during the in-class quizzes, which will take place during your computer lab tutorials. And so to prepare for this, first thing you should do is make sure you can answer all of the questions that you'll see in blue boxes to the right of the slides. And the second thing you should do is go into our special software called Question Hoard, which allows you to test yourselves on a whole load of questions that you might get asked in the quiz. So I'll be demonstrating Question Hoard during the very first presentation in week 1, and you'll find Question Hoard in the main menu on the Psych 3020 Blackboard website. The content of this presentation includes number 1, scales of measurement, 2, the normal distribution, z-scores and percentile ranks, 3, correlations, 4, research methods that could be used for program evaluation, and 5, APA 7th edition format. So, scales of measurement. There are 4 scales of measurement: nominal, ordinal, interval, ratio, or NOIR. Okay, and so when we talk about nominal scales, nominal means as in names. Another description of a nominal scale is a categorical scale, as in categories. So this is where there are discrete categories, discrete ways of classifying the various different things within your data. The traditionally classic example of a nominal or categorical scale would be something like gender, so male versus female. But this is one of these things where nothing's ever cut and dried in psychology, and this is one example where some people have argued it's actually not appropriate to treat males versus females as a purely 2-category scale. And so, for example, to deal with this in my own questionnaires, always include a third category, which is other, in case people object to labelling themselves as either male or female. Let's look at some examples of nominal scales from other disciplines. So the reason I'm doing this is just to try and make a point to you guys that when we are going into measurement and talking about measurement, these are things that apply not just to psychology, but can be applied to measurement in pretty much any other domain. Okay, so here's an example from astronomy, classifying things as planets, say, versus stars. That would be an example of classifying things on a nominal scale or categorical scale. Or human physiology, liver versus lung, 2 different things. There's no sense of a sliding scale between the two, and therefore that would be a categorical or nominal scale. Now, what I'm going to do during all of these presentations and also the live presentations is to talk about these blue boxes on the right. So to the right of the slides, you'll find a whole number of questions, and these are supposed to prime you as to the sorts of questions you should be able to answer based on the slide content in the quizzes or the tutorial worksheets. Let's start with this one. True or false? A categorical variable can always be measured using a nominal scale. That's true because categorical and nominal are essentially referring to the same thing. So the answer to that would be true. Next scale of measurement is ordinal. And ordinal as in this is a situation where things can be placed in some sort of rank order. However, in an ordinal scale, the distance between objects when you rank them isn't necessarily meaningful. So let's look at some examples. Political parties. We can probably take political parties and we can usually rank them from left wing to right wing in a way that most people would probably agree with. Okay, so here we go. So some Australian political parties for you. So maybe people would describe One Nation as very right-wing, Nationals as slightly less right-wing, Liberals as slightly less right-wing than that, Labour as starting to get a bit left-wing, and the Greens as more left-wing than Labour. That would be an example of an ordinal scale, because at no point are we claiming, for example, that that One Nation are twice as right-wing as the Nationals. That concept has no meaning on a scale like this. It's just an order that is meaningful, not the distance between each of those things. In sports, where we hand out gold, silver and bronze medals, again, that's another example of an ordinal scale where the order of those medals is meaningful. So gold is always better than silver, which is always better than bronze, but we're saying nothing about the relative distance between them. So it's not the case that, say, gold is twice as good as silver, which is twice as good as bronze, or anything like that. Here's an example from clinical medicine. So in clinical medicine, when you want to measure someone's level of consciousness, people very often use what's known as an AVPU scale. And AVPU is an acronym that stands for alert. So that's the first point on the scale. This is where you've got your patient and they're conscious and they're clearly alert and you can talk to them and so forth. The next level on the scale is V for voice. This is where they might look like they're unconscious, but if you call out their name, they'll respond to your voice. Okay, the third level down is P for pain, and this is where maybe that they're a little bit, they look unconscious, they don't respond to your voice, but if you do something like sort of squeeze their finger or something like that, they will show some level of response to that stimulus. Okay, so that they're responding on some level, but they wouldn't responding to your voice, and they're obviously not alert. Okay, and the final level is unresponsive, that you can pinch them all you like, and they just won't respond, which means they're completely unconscious. So, AVPU scale, classic example of an ordinal scale, in that you can put those four things in a rank order, but we're making no assumptions as to the relative distance between each of those four levels. Let's look at the questions on this slide. So, true or false? In soccer, the team with the highest number of goals is categorised as the winner. The other team is categorised as the loser. This is an example of a nominal scale. Okay, so the answer to that is false. And it's false because when you've got winners and you've got a winner and a loser there in that example, those can be clearly put into an order. So presumably winning is usually better than losing. Therefore, that would be an example of an ordinal scale, not a nominal scale. Okay, next question. In an art competition, there is one winner decided by the judges, a second place decided by the judges, and a separate People's Choice winner decided on by the public. The rest of the entries are designated losers. This is an example of an ordinal scale. On the face of it, it might look like an ordinal scale, but there's an important exception there, which is that we've got this separate People's Choice category, and it's not clear, at least there's no information there, about how that People's Choice category ranks relative to the other categories, the sort of the winners and the losers decided by the judges. And because we can't rank order that People's Choice, then that means that this can't be an ordinal scale. So if we remove that People's Choice, it would be an ordinal scale. But if we include that People's Choice, then it can't be an ordinal scale, which means we would have to deal with it as if it were a nominal or categorical scale. So the answer to that is false. Next scale of measurement is interval. So, as in interval between things now is becoming meaningful, but for an interval scale, the 0 point is arbitrary. Okay, so classic examples of interval scales from other disciplines. Temperature, if you measure it in Celsius or Fahrenheit, is a classic interval scale because the distance between the units is meaningful. However, the 0 point is arbitrary. So in Celsius, for example, the 0 point is the melting point of water. That doesn't mean there's an absence of temperature, it's just been arbitrarily chosen as a convenient sort of marker. Okay, so a convenient thing that's easy to measure, but it doesn't mean if the temperature is 0 degrees Celsius, it doesn't mean that we have a complete absence of temperature. Okay, so that means we can't say, for example, that 80 degrees Celsius is twice as hot as 40 degrees Celsius. That doesn't actually mean anything. Another example, time of day. So another thing where it's an interval measurement, because it's meaningful to say, between 12 o'clock and 2 o'clock is 2 hours, and 2 o'clock and 3 o'clock is 1 hour. So the distance between measurements, between points on the scale is meaningful, but there's no a 0 point. There's no point at which we say, there's a complete absence of time here. Alright, and likewise with day of the month. Okay, true or false? Temperature as measured in degrees Celsius is a ratio measurement. The answer is false. No, it's a interval measurement as just explained. Alright, final scale of measurement is ratio. So as in the ratio between things now becomes meaningful because the 0 point is an absolute thing. That means the thing, whatever you're measuring, is not there, is absent. Example of this would be distance. You measure a distance with a ruler. 0 actually means there's no distance there. What that means by having a proper 0 point is that, for example, 20 centimeters is actually twice as long as 10 centimeters. We can make that ratio level judgments. Money, yeah, so basically you can say, $100 is twice as much as $50, and $0 means you don't have any money. So 0 point is meaningful. Timing in seconds, so 10 seconds is twice as long as 5 seconds, and 0 seconds means no time has passed whatsoever. That's a meaningful thing to say. Right, true or false? If we can state that the score on a measure is twice that of another score on the same measure, then these scores must have been gauged on an interval scale. True or false? That's false, because they must have been gauged on a ratio scale for that thing to be true. A ratio scale where the 0 point means an absence of whatever you're measuring. So, we've talked about scales of measurement in lots of different disciplines. Let's talk about scales of measurement specifically in psychology. Generally speaking, scales in psychology are often, strictly speaking, they're ordinal rather than interval. That is, for example, when we're measuring something like intelligence, you can make the argument that the difference between someone with an IQ of 120 and 110, that's 10 points, that difference doesn't mean the same thing as the difference between someone with an IQ of 70 and 80. Okay, even though they're both 10 points, that doesn't mean that that's the same difference in intelligence. You want to be really strict about it. This means a typical traditional intelligence scale would be an ordinal measure, not an interval measure. However, and that's a big however, it's the case that if you actually look at how these scales perform when we do statistics on them and when we do assumption tests on them, they generally approximate the properties of having interval equality pretty well. So that is, even though they're technically ordinal scales, they behave well enough like interval scales that we can essentially treat them as if they're interval scales. Why would we want to treat something that's technically an ordinal scale as an interval scale? This is because if we can treat things as interval scales, we can do more sensitive statistical analyses on them. Okay, specifically parametric tests. We can potentially use parametric tests for interval and ratio scales. When we use parametric tests, this requires us to make assumptions about the underlying distribution, and those assumptions we need to be true for those tests to work. But if we're using either nominal or ordinal scales, we instead need to use non-parametric tests, so don't have these assumptions, but they're also less sensitive. Generally, if we can say the scale is interval or ratio, we can use parametric tests if we meet the appropriate assumptions. But if our scales are nominal or ordinal, then we have to use non-parametric tests, because non-parametric tests require fewer assumptions. Okay, they don't require us to make assumptions about underlying distributions. True or false? Measurements using the ratio scale always require the use of non-parametric statistics. No, that's false, because there'll be lots of ratio scales there that would meet the assumptions of parametric statistics, and therefore there are situations where we can use parametric statistics. Is it the case that we can always use parametric statistics when you've got a ratio scale? The answer to that is no, because there might be situations where the scale is ratio, but your parametric statistic requires, for example, a normal distribution, and the scale doesn't have a normal distribution. Okay, second question. Strictly speaking, a typical intelligence test is an ordinal, not an interval measurement. Yeah, so that's answer that is true. Strictly speaking, intelligence tests, aptitude tests, personality tests, they're all strictly speaking ordinal, and they're not interval, but we tend to deal with them as if they're interval for the reasons I discussed earlier. Alright, third question. We generally treat psychological scales as if they're ratio, even though they're technically interval scales. That's false. So we tend to treat them as if they're interval scales, even though they're technically ordinal scales. Fourth question. We tend to treat psychological scales as being interval scales, so we can do non-parametric tests on them. So that's false. The way I could change that to a true answer would be to change it to, we tend to treat psychological scales as being interval scales, so we can do parametric tests on them.